Okay, so lastly in 9.2 we are going to perform another hypothesis test, and we're going to use the p-value. It's going to give us the same result as if we use the critical, but instead of the critical value, we're going to be comparing the area under the curve to the level of significance. So if the area under the curve to the point of the test stat is less than the level of significance, you reject the null. If it's greater than, you do not reject the null. I'm going to draw a picture for this hypothesis test so we can see what that means. Okay, so for this hypothesis test, the mean height of adult men is 69.7 inches with a standard deviation of 3. Sociologist believes that taller men are more likely to be promoted in positions of leadership. The population mean is 69.7. The population standard deviation was 3. In a simple random sample of 100, we have a sample of 100 male business executives. The sample mean height was 69.9. Alright, so can we conclude that the male business executives are taller? That's going to be greater than. And we're going to use a 0.05 level of significance. So first we have to set up our null, which is always going to be equal to the mean, and our alternative hypothesis is greater than. So it's a right-tailed test. Our test statistic is going to be the sample mean minus the population mean divided by standard deviation divided by the square root of the sample size. Let's plug those in regular pencil. When I put this in my calculator, I'm going to get the numerator. Sorry, you can't see this. Here we go. Divided by the denominator in parentheses. Square root of 100. .67. I'm going to round that to, and that's my z-test stat. So here we have a right-tailed test. So if I have 0.05 level of significance, that's this right here. I don't need to get my critical z value because we're going to use the p value. What I do need to do is I need to figure out where this 0.67. So my test stat is going to look like this. Okay, so say I have 0.67. The p-value is the area up to this point. Now, that's positive 0.67. I want to the right of, so what I'm going to do is I'm going to use my yellow table and do 1 minus the table to get the area shaded in blue by my test statistic, which is the p-value. So 0.67 on my normal distribution, 0.7486. So 1 minus the table, because I want to the right of. So 0.2514. So instead of getting my critical z-value, what we're going to do is we're going to compare this blue shading to the red shading. The p-value is 0.2514. The red, my level of significance, is only 0.05. The p is greater. That means it makes its way out of the critical area. It's out to here because it's greater than. So we fail to reject the null. If we fail to reject them, that means they're right, we're wrong. We do not have enough evidence to support our claim. So the p-value is greater than the level of significance. And back up here, if the p-value is lower than the level of significance, it means it wouldn't be big enough to get out of the critical area, and that means we would reject them. But because it's larger, it made it out of the area, and we failed to reject them, the null.